Well, welcome everyone to BSidesSF 2025. You find yourself in Theater 6. We would love to introduce our next presenters. We're going to be talking about data splicing attacks. And here to tell us all about that are Vivek Ramachandran and Audrey Adeline.
Okay. All right, much better. Hi, everyone. Today we're going to be talking about a new class of attacks that we discovered called data splicing attacks and have some fun breaking enterprise DLP. So just a quick introduction. My name is Audrey. I'm a security researcher at SquareX. There I lead a project called Year of Browser Bugs. So it's really a tribute to the earlier Month of Bugs project in the mid and early 2000s. And since at the start of this year, we've been releasing a couple of architectural vulnerabilities in the browser and attacks that leverage them. So we'll continue to do so as well. The other thing is we've also published a book called The Browser Security Field Manual. So we actually have a couple of copies on hand, and my colleague Sasha, do you want to wave? We have a couple of interesting questions, so if anyone can answer them, we'll give you a free copy as well. And prior to that, I spent a couple of years at Sequoia Capital, where I was advising on cybersecurity investments. And I actually came from quite an unconventional background. So a quick fun fact on why we call it data splicing is because it's a step that removes noise from your mRNAs before it can be read meaningfully and translated into proteins. So that kind of reflects my biochemistry background, and I hope you'll see why we named it that throughout the talk. So someone else who's really instrumental to the data splicing research is my colleague Jeswin. He's the chief architect at SquareX, but unfortunately, due to some last-minute issues, he was unable to join us today. But he did record a quick video to say hi to all of you. So we'll just go ahead and play that.
Hello everyone, this is Justin. I'm the Chief Architect at SquareX. And in this session, we'll take a look at some very interesting techniques on enterprise DLP solution. Unfortunately, due to some last minute visa issue, I could not make it to present there, but regardless, you're in the best hands and I hope everyone will enjoy the session. Hello.
All right. I also like to give a shout out to our research team, who without their help, this research wouldn't have been possible. So huge shout out to Dakshita, Pankaj, Arpit, and Tejeswar as well. And then before we get into the meat of it, I'd like to introduce our founder, Vivek. He can introduce himself as well.
I'm the manager who funded the project and the travel and accommodation. That's why you see me here. So I'm Vivek, been in cybersecurity 25 years, started on the offensive side, founded a bunch of companies, Pen Tester Academy. Now I'm doing SquareX, spoken at DEF CON, Black Hat, I think 20-25 times. The key thing, of course, which I've loved doing and the rest of the team at SquareX as well, is spending a lot of time looking at bleeding edge security. And one of the main things of interest to us recently has been enterprise security products. So over the past 2 years, we've spent a lot of time breaking enterprise security. We went ahead, put out research on secure web gateways, Google's MB3 architecture, much of it presented at hacker conferences around the world. Now, carrying on that tradition this year, we wanted to take a look at DLP, and specifically in-browser DLP. The reason why DLP is so interesting is almost every organization has DLP incorporated in some shape or form. And you have endpoint DLP and you have cloud DLP. And what we've started seeing is, given that the browser is the most used application, whether existing DLP solutions are able to cover the browser properly. And that was the whole thing which led to the research. We ended up looking at a lot of enterprise solutions, trying to see if attackers, insider threats, all of that could subvert DLP at this point in time using the browser.
Right, so I've been told that as security people like structure, so quickly running through the agenda for today. We've already done the introductions, but before we go into the demos and the meat of the conversation here, I thought it would be helpful for us to go over a quick recap on how enterprise DLP work, how their architectures are built, and what are some of the fundamental limitations that we're exploiting here. And then we're going to move on and show you 5 techniques within data splicing and how we can use them to bypass DLP solutions. And we're also going to be releasing an open source toolkit called Angry Magpie. So don't worry about taking any videos. We'll make sure that you guys have access to all the kind of attacks that we're releasing today. And last but not least, we'll save up some time for key takeaways and questions as well. So let's quickly look at enterprise DLP. What do we really mean by enterprise DLP here? Primarily, there are 2 DLP solutions when it comes to enterprise user workflow. So the first is endpoint DLP, and the second is SASE SSE proxy DLP. Now, both of them primarily identify sensitive data in 2 ways. The first is they look at tags, files that are tagged as sensitive, and the second is they use some policies that use regular expressions, and we'll go into a little bit on how regex works later. But in terms of where they sit, endpoint DLP typically sits at the interface between where data enters and leaves the device. So think when you upload or download files to and from the browser, while SASE and SSE proxy DLP inspect network traffic to see if there's any sort of abnormal requests or sensitive data that's being requested by sites that are unauthorized. And to some extent, some of the more advanced one can also check for unauthorized users as well. But if you take a deeper look at how these endpoint DLP solutions work, they don't actually have any direct visibility into the browser. Most of them rely on browser APIs that are opened up by vendors like Chrome. So for example, the clipboard API allows them to inspect the clipboard in the browser and the contents. Similarly, the file upload and download API allows them to inspect data in files that are uploaded and downloaded. So essentially, if you think about it, they don't actually have any real context on the user workflow, and the user workflow is really a black box for these endpoint DLP solutions. So they don't have the ability to differentiate between identities. So let's say if you're downloading a file from Gmail, they have no idea if it's your personal account or your work account. And similarly, they have no context on page content, network requests, and can protect on specific data leakage vectors in the browser, such as things like info sealer, browser extensions, credential leakages, and so on. And I think the key thing to highlight here is that not all endpoint DLP solutions actually have access to these APIs. Only if you're whitelisted by Chrome can you get access to these. So does anyone have a guess on how many vendors out there are actually whitelisted and have access to these APIs? Anyone? You get a free book if you do. 17? Any other guesses? It's lower than that. So it was 5, 17, and less than 10. 2, that's right. So today there's only 2 vendors to our knowledge that have access to these APIs. So Sasha can share with this lady one of the books. So the only vendors that have it is actually Trellix and Symantec, who's acquired by Broadcom. So that's kind of insane, right? Imagine like out of all the vendors out there, only 2 have any form of visibility into the browser. And even if they do, it's very, very limited APIs. So just for the fun of it, all the demos that we show you guys today for endpoint DLP will actually go ahead and use Chrome Enterprise DLP instead. The reason is because as Chrome, they have the fullest set of APIs, right? And I hope this will convince you that even if one day they open up all the APIs, the data splicing attacks that we show you guys today will still work. So what about SASE and SSE proxy DLP solutions? They work by inspecting network traffic at the proxy layer. So without direct access to rich browser metrics, similar to endpoint DLP, they don't have any understanding on what web app the users are using and how they're interacting with it. And to inspect any data, the way it works, it actually has to be sent to the provider's cloud. And as many of you know, this leads to a lot of latency issues. So the way that a lot of SASE and SSE solutions solve this is they would limit the size of the files. I believe most of the large vendors, and this is all public information, only scan files up to 120 megabyte. So anything above that, it's either a blanket block or a blanket allow. And additionally, there's also a myriad kind of data leakage channels that they don't inspect. So think your encrypted files, your binary channels, browser extensions, third-party app APIs, and so on. And even if they're able to detect this data, oftentimes they don't have access to things like DOM changes, tab context, or user interaction to figure out exactly how the data was lost and prevent similar attacks in the future. So I think the key takeaway from these 2 slides is that neither endpoint or proxy DLP have direct visibility into what employees are doing in the browser. So to understand why there's a bit of a mismatch between existing DLP solutions and the DLP protection that we need to look at how the way we've worked changed in the past 2 decades. So thanks to the proliferation of clouds, 80% of enterprise data is now stored on the cloud. And in the past decade, another thing that has happened is we've seen a lot of browser technologies like WASM and WebRTC being developed, and this is probably largely thanks to Chromium being open source. And the result of this is the web app experience has improved significantly. A lot of them has now matching experience to native apps, and as a result, more and more enterprise workflow is now moving to SaaS apps. In other words, the bulk of enterprise data today is actually being stored, created, shared, and accessed through the browser without ever even involving the endpoint. So quick question, is there anyone in the crowd that's a student or a recent graduate? I know there's some friends from Stanford here. But I was speaking to a lot of my younger cousins who recently graduated, and most of them don't even use a single local app for their work, right? They spend the majority of their working hours on apps like Google Docs, Figma, Salesforce, which are all SaaS apps. And even traditionally native apps like Photoshop or Office 365 Suite now have a SaaS version as well. And similarly, we rely really heavily on services like Google Drive and OneDrive to store and share files. So the number of files that we are downloading nowadays are becoming much and much lesser. Despite this, most of the DLP solutions that we saw earlier are really focused on the endpoint and the proxy layer still, and it does not take into account data leakage in the browser. So if there's such an obvious behavioral trend, why do you think incumbents haven't developed stronger capabilities in the browser? And the truth is, it's really not easy. There's a lot of challenges that's unique to browser DLP. So for example, there's a lot of data access paths they have to think about. It's not just clipboard, it's not just file upload and download that are regularly included in DLP, but also data access paths unique to the browser. So these are things like SaaS app data integrations, how different apps are sending data to each other, binary channels, browser extensions, and so on. And the other really unique thing about the browser, it's probably the only app that's being used for both personal and work use cases. So if you think about, let's say, your Gmail or your Google Drive account, most of you probably have a work account and also a personal account. So it's really hard to implement certain policies where you have to think about balancing security and privacy, especially as more laws like GDPR come up. And in addition, when it comes to your typical device, a lot of companies just have managed device where they have full control on whatever apps they want to control. But when it comes to the browser, pretty much everyone with an email or a credit card can sign up to a SaaS app in 5 minutes. And the last point isn't really something that's super unique to the browser, but it is an issue with a lot of data loss DLP providers, so I just wanted to highlight it. And this is the point around data complexity, right? There's a lot of data types that you have to take into account too. So when it comes to files, we already saw the limitations of SASE SSE when it comes to different file types, sizes, and executables. And when it comes to memory buffers, not only do you have to inspect system clipboard, you now have to take a look at how it interacts with the browser clipboard as well. And again, the definition of sensitive data varies widely between companies, jurisdictions, industries, and so on. And of course, there's encryption technologies that you have to take into account as well. All right, so now on to the most interesting part. So as I mentioned today, we'll be covering 5 data splicing techniques. But before this, I think it's really important for us to understand what are we really exploiting this. So I'll invite Vivek back up to share that.
So what we are assuming for this talk is you have endpoint DLP, which is connecting via browser APIs. And as she mentioned, we're going to be using Chrome Enterprise, because that has the fullest set of most rich APIs at this point in time. And then we are also going to layer that up with SASE SSE secure web gateways, because most enterprises tend to use that as a way to actually look at files and make sure DLP is in good order. Now, what are the architectural vulnerabilities? So let's actually start with SASE SSE secure web gateways. The way a DLP policy triggers, and if we just pick up files, is a secure web gateway is looking at file headers in network traffic, and the moment it detects that a file is being uploaded, it immediately caches that file in the cloud, goes ahead, applies whatever DLP policies that you have put out on that file. Now, interestingly, if in some way an attacker can make sure that the solution can't even detect a file upload, what that means is nothing ever triggers. Now, this has been happening in 2 different ways. One is attackers and the other is UI frameworks. Interestingly, most modern UI frameworks, because you want to be super responsive, end up using binary protocols like WebSockets, gRPC, WebRTC, and whatnot. And these are literally just binary channels, which is there's no real way of knowing unless you are the application author as to is a file being sent, is this audio data transcoded or what's really going on in between. And this is really where more and more applications automatically are starting to bypass DLP anyway. The second part, of course, is attackers are taking a look at this and they've been abusing this a lot as well. So I'll give you examples. How many of you use WhatsApp, web WhatsApp, Telegram? If you upload a file via web WhatsApp or Telegram, that actually just uses WebSockets. So you should be able to send in a credit card file or a P2 information file right through the SASE SSE proxy. So that is one piece which Audrey will talk about a little later. But coming back to the first piece, Chrome Enterprise, our perspective is that this is still very early. So if you are the browser and a file is being uploaded, ideally you want to make sure that every path of that file getting uploaded, processed, you are able to monitor that. Because if you don't, then an attacker can insert himself, inject himself somewhere in between and make changes. And this is exactly what DLP splicing is when it comes to endpoint browser-based API bypasses. And then later we'll talk about secure web gateways.
All right, thanks, Vivek. So the first technique that we're gonna uncover is what Vivek mentioned earlier on these communication channels. So how many of you guys have heard of WebRTC, Firebase Cloud Messaging here? Anyone? All right, so these binary channels, they're used for a lot of communication protocols. So for example, WebRTC is being used for P2P communication. So think about your audio and video conferencing apps. And then Firebase Cloud Messaging, as stated in its name, is used for a lot of notifications for web apps and web transport, low latency data exchanges for a lot of your games. So this is a bit of a catch-all attack because, as Vivek briefly alluded to, these binary channels are completely uninspected by both SASE SEC DLP solutions or endpoint DLP solutions. So the attacker can pretty much smuggle any data they want through these channels without any inspection. And the reason this has happened is because a lot of these communication protocols are only invented in the early 2010s to mid-2010s. And that was way after a lot of the DLP solutions has been built. And truth to be told, the adoption took some time. So it was only in the past 5 to 10 years that you started to see it widely being used. So I think just a quick evidence on how SASE and SSE don't cover this. A lot of the SASE and SSE solutions actually state publicly on their website that this is something they don't cover. So a lot of the complex protocols, as you can see in Zscaler's website, what they have said here is, we can't inspect quick, and the best practice is to just block it. And similarly, there's an example for Palo Alto Networks for WebRTC. And of course, for every security practitioner, the safest way to be safe is just to block everything. But as you know, this is not realistic, especially as most modern tools like video conferencing tools, apps rely on a lot of these protocols to work properly. So first, let's take a look on how SASE and SSE solutions work. So we've created a sample application here, which we'll also make open source later on, where you could upload files in different ways. So right now, we're just doing a normal file upload without the SASE and SSE solution on. Here, it contains some credit card details. And given we have no policies on, it was allowed. But now we'll go ahead and turn on the SASE SSE DLP solution. And we'll see that they're going to go ahead and detect that there's a credit card number, and the file upload would be blocked. All right, so how does it work with these data smuggling via alternate communication channels? So as Vivek mentioned earlier, the way that SASE and SSE figure out that a file upload is being triggered is they look at HTTP headers and other heuristics to figure out, okay, there's a file being uploaded. Let's go ahead and cache it and send it to our cloud and compare it to a bunch of DLP policies. If one of them hits, then we'll go ahead and block the download, and if not, we'll allow it. So here is an example where we've used WebSockets. So instead of doing the normal file upload, we'll go ahead and upload it through WebSocket. And as you can see, it completely bypassed SASE and SSE solutions, and the attacker can view it on their servers. Now, the next technique is called data sharding. before we go into what it is, we should quickly take a look at how regular expression works. So a lot of enterprise DLP solutions, as we mentioned earlier, rely on regex to figure out PIIs like social security numbers, phone numbers, credit card numbers. So this is actually regex for social security numbers. It basically says that, okay, you have a sequence of 9 numbers that comes in groups of 3 followed by 2 followed by 4, and neither of these groups should have, all zeros. And for the first group, you want to make sure it's not triple sixes or any number between 900 and 999. And as long as all of these requirements are met, it's a social security number, and we should go ahead and block the upload of this file. Now, so what we're doing in data sharding is basically because we know that there's a specific sequence that we're looking at, then why don't we go ahead and break the file into small shards? And the key thing here is you want to break it to such a small shard that it's much smaller than the regex detection sequence, such that the individual shard will be able to bypass SASE and SSE solution because they're not long enough to trigger any regex rules. And then once they bypass SASE and SSE, the attacker can then go ahead and reconstruct the file on the server side. So here's a quick demo on how it looks like. So this is the same file as earlier. We'll go ahead and shard the data into smaller sizes. And this application will allow you to decide on the size. And again, the key thing is as long as the size is smaller than the regex you're trying to evade, then it should be able to bypass the policy. So here we've done 100 bytes just for the sake of example. And you'll see that the individual shards would be able to bypass SASE and SSE solutions. And once everything is collected by the attacker, they can go ahead and reconstruct it, and you'll be able to see the file in its original state. All right, and the third technique here that we'd like to share is called data ciphering. Now, I think we briefly covered this in the beginning, but most SASE SSE solutions cannot detect encrypted files on the client side because they don't have the decryption key, especially if they're encrypted in the endpoint or in the browser. Now, when a SASE and SSE sees an encrypted file, 2 things can happen. First, they can either blanket block and say that any file that are encrypted, we won't allow upload or download. The second option, which is the most likely option, is that they'll allow the upload without any inspection. So if we go back to the application earlier, we'll go ahead and upload an encrypted file. Well, actually, this file is going to be encrypted on the client side by a JavaScript. And the key thing is you can use any encryption technology that you want. We've used a pretty simple one here, but I think this just shows you that no SASE and SSE solution can go ahead and figure out and decrypt these files on the fly. So once the content is being encrypted, it can bypass SASE and SSE solutions. And the attacker can then go ahead and decrypt the file and gain access to it. Okay, so the next technique that I'm going to share is actually one of my favorite ones just because it's so elegant and so simple. So this technique is particularly effective against regex-based policies. And the reason is, if you remember, regex has to work in a very specific sequence. So the moment you encode the data and turn it into a different format, it completely breaks the detection. Because this way, the encoded message, in this case, the social security number, will no longer meet the regex requirements needed for detection. So here again is a demo where we're going to add a JavaScript to any file that you're trying to upload, which will go ahead and encode it using base64. And the reason why we picked base64 here is because we just wanted to show you that we're using a very simple encoding method that everybody knows about. So this really shows that SASE SSEs don't have the ability to detect encoded data and much less decode it. So what happens here is once the encoded file is being uploaded, similar to the encryption one, the attacker can go ahead and decode the file and get access to everything that's inside. All right, so now we've given enough paint to SASE and SSE solutions, so let's take a look at endpoint DLP. So just quickly, we'll show how Chrome Enterprise DLP works. And as mentioned earlier, we're using Chrome Enterprise just because they have the full suite of API access. So here, a policy is being created for credit card numbers, and we'll go ahead and apply it to different data leakage vectors, including copy-paste, file upload, download, and printing. And we'll go ahead and bypass it one by one later on. Here you can, of course, do your own regexes, but I think Chrome also comes with a set of different regular expressions for things like credit card, social security number, and so on, but it's the same technique. They're also using regular expressions. So we'll go ahead and apply that. And then after that, it's just adding, the severity level or the likeliness level, and kind of the action that you want to happen. So in this case, we'll just block it. All right, so now let's take a look at how we can bypass each of these actions using data transcoding. First, let's take a look at file upload. And in order to do that, it's important to understand what exactly happens when you upload a file. So when you trigger a file upload, let's say by clicking an upload button in any SaaS app, what happens is the endpoint DLP solutions will go ahead and inspect this file using the file upload API. And if it does not trigger any DLP policy, only then will the file get uploaded to the browser, and then it gets sent to the service provider. So in a data transcoding attack, the attacker or the insider threat will already encode the file in their own device before uploading it. And after it passes the DLP checks, it'll go ahead and decode the file before it sends it to the service provider. And the reason why we've done this instead of just sending it directly to the attacker server is to show you that this attack works on pretty much any SaaS app that you want to exfiltrate data to. So we just take a quick look here. This is the same policy that we've implemented earlier. So any file that contains 2 or more credit card numbers should ideally be blocked by this DLP policy. So just quickly show you that, without data transcoding, this will go ahead and be blocked by Chrome Enterprise DLP. Okay, so now what we're gonna do is we're gonna encode the file before we upload it. Again, we're using a very simple method, base64. And once the file is encoded, we'll go ahead and hit upload. And because now it's in an encoded form, there's no credit card number being detected. And we're going to add a piece of JavaScript to intercept the file upload after the checks has been done by endpoint DLP and base64 decode it such that when you upload the file and open it up in Google Drive, it'll actually look exactly the same. So there you go. For the attacker, it looks exactly seamless. It doesn't seem like any blocking or any decoding method has happened. All right, so now we'll take a look at file download. And this is a very similar concept to file upload, except it's reverse. So when a file download is being triggered, the file is actually fetched from a service provider, and then it gets inspected by the DLP solution using the file download API before it gets downloaded to the endpoint. And the key principle remains the same here. You want to encode the file before the inspection happens, and you want to decode it before the end user or the attacker sees it. We'll take a look at how this works. I believe in this case, we're using Zoho as an example. But again, you can use any enterprise or consumer SaaS app to do the download. So typically, the DLP solution will go ahead and block the file download from any app that contains credit card numbers. But what we're going to do is we're going to go ahead and add a piece of JavaScript that will go ahead and fetch the file. And then we're going to go ahead and encode it with base64 and then trigger the download. And again, at this point, because now it's no longer in the format of credit card numbers, it won't be detected as suspicious by the DLP solution, and the download will be successful. So I'll just quickly skip through it. Right, so this is the downloaded file. We can go ahead as the attacker, in their device, go ahead and decode the file. All right, so what about copy-paste? So copy-paste is a little bit more unique because there's kind of 2 operations where you can apply the DLP policies to. It's usually applied upon the copy function or on the paste function. And as the attacker, you don't really know which policies it's applied to. So just to give you a brief preview on how this works, we'll go ahead and copy some random text and paste it in a paste bin. You'll see that this is successful simply because it doesn't contain any credit card numbers. But the moment we go ahead and copy the text from earlier, given that it contains multiple credit card numbers, it'll be blocked by the enterprise, the endpoint DLP policy. So how are we going to go and evade this? And as I mentioned earlier, the attacker doesn't know what exactly is the policy being applied. So just to be safe, we're going to add 2 pieces of JavaScript. So the first is going to be at the paste side. So here, what we're going to do is going to assume that anything that's on the clipboard is already base64 encoded. And we want to go ahead and decode it and add it to the text area. This is to evade any sort of paste policies. Now, on the copy side, what we want to do is we want to also make sure that any kind of data that is added to the clipboard is already in encoded form. So the JavaScript that we write here is going to read the selected data, encode it in base64, and print it on the console, such that any data that is being copied onto the clipboard is already in the form that is encoded. So this way, we can evade both the copy policy and the paste policy. All right, and another question that we often get is like, hey, what about printing? It's a very common way that insider threats like to smuggle data out. So this is a technique called data insertion. And again, going back to how regular expression works, you want to make sure that the format of the data type that you're trying to inspect is in a specific format. So what we can do is you can insert a piece of text or a character in between each character in the file, such that when it reads it, it's gonna break the regular expression for credit card numbers. So just to make the experience even better, we can add these texts in a very small kind of size and also turn it into white, such that when you actually print the file, it'll look exactly the same. But really what it does to the endpoint DLP solution is it completely breaks any regular expression rules. And even if you don't know whether there's credit card number, you can just add it into between any characters that you see on page. So we'll go ahead and view the file. And as you can see, it just looks exactly the same to the end user. All right, so those are the 5 techniques that we wanted to show you. And I think we're reaching to the end of the talk, but we'd also like to share with you an open source toolkit that we've created for any of you that want to test this back with your enterprise security stack. So any pen testers or red teamers here? Okay, just a few. So if you're interested, you can go ahead and go to our GitHub. We're gonna release this, I think, an hour of this talk after this talk. So what we've done is there's going to be 2 things over there. The first one is the application that we showed earlier for the SASE SSE bypass. So all of that you can test out. And the second one is all the text that we've shown for endpoint DLP bypass. We've actually created a browser extension for it. And the reason why we've used browser extension is because it can inject JavaScript into the browser. But of course, if you want, you can also use the developer console just like we did. And one thing that I like to mention is I love to take credit on building up the code for this repo. But to be honest, most of this are done using the free version of ChatGPT and Claude. So this just really shows you how trivial it is to break enterprise DLP solutions. All right, so before we end, I'd like to invite Vivek up for some key takeaways.
The whole talk almost felt like a bad commercial for enterprise DLP. So, what is fundamentally broken here? How many of you love writing regular expressions or copy pasting that in your DLP solutions, right? So I think the whole DLP industry hasn't innovated much probably in the last 15 to 17 years. Much of it is still run by regular expressions, which is amazingly shocking in this day and age for you to just go ahead trying to search for patterns and strings and whatnot. So that's the very first part which we feel is very easy to break. And what we've tried to show here is very trivial techniques, right? I mean, much of it, base64 encoding. I mean, it's been around since probably the early web. It's so easy to detect that something is base64 encoded, and most DLP solutions don't even have the ability today to actually figure that part out. So I think the first takeaway is enterprise DLP, at least in our humble view, is broken. There needs to be a big disruption happening. Today's world of LLMs, where you can actually parse text, get inferences, I'm hoping that's where DLP is going to move, where it starts to become more inferential rather than pattern searching. The second part, of course, is the browser is the only unmanaged application at this point in time on managed enterprise devices for the most part. Very few enterprises manage the browser. Very few enterprises lock it down. While what we forget is the browser is a full compute machine, right? You can run code, do whatever you want, transform data, encode it, encrypt it on the client side. Fairly easy to go ahead and create bypasses for both cloud as well as endpoint DLP with browser APIs. The second thing, what we also feel at this point is most browser vendors have not opened up really powerful APIs for endpoint DLP to go ahead and access what's happening. Because if you think about it, like if all you're looking at is a file upload is happening via Chrome browser, all your work gets done via the browser. Every single app you use for the enterprise today is a SaaS app. And this is really where it's expected that all files probably go through the browser. How many of you still use USB keys? Probably barely anyone, right? Network file systems. Sharing of files within the enterprise, right? Almost makes me sound dated now. Most of the young folks don't even know what that is. And this is really where, if that's the gateway device, that is the gateway application, makes sense for all browser vendors to go about working on it. Now, what we find, of course, is that Chrome and Edge are a little bit ahead. You can try out similar examples with Purview. Nothing changes. When it comes to Firefox, Safari, all of them, they lag behind like anything. Much of it you can't even do at this point in time when it comes to any form of in-browser monitoring. Now, the second part, of course, is the whole SASE SSE. That was a great promise. And the promise was you don't have to have anything on the endpoint. You can send us all your bad traffic. We are going to take a look at it, clean it up for you, send it to the destination. When things come back, we're going to do the same thing. You don't have to worry about deploying anything on-prem. But what's really happened is when these technologies came to be, that was probably around 10 to 12 years back, it was easy to look at network traffic and recreate what was happening in the application layer, right? Many of you may remember the times where you had to hit the refresh button on Gmail and Yahoo Mail. But now, applications are super complex, UI frameworks are complex, everything is an API. Real-time binary stream communication is more the norm than the exception. And this is really where, without really taking into account all of those nuances of how browser tech has really changed over the years, at this point in time, it's impossible to look at network traffic and recreate what's happening at the application layer. Beating SASE, SSE, SWGs, we had a very detailed discussion we did a while back at DEF CON last year. In my humble view, is almost hilarious. And to see most enterprises depend on that as the primary way to block insider threats, data exfiltration and whatnot. So I think in conclusion, what we wanted to say is, at this point in time, the browser is the weakest link, fairly easy for insiders and attackers to exfiltrate data, do things via it. Browser vendors have to step up their game first, allow a lot more fine-grained controls so that you can do many of the things that you could happily do at the endpoint by just interfacing with APIs, Windows, Mac, Linux, whatever gives you. You probably need an equivalent capability in the browser. Second, SASE SSE as an industry needs to probably expand its perimeter into the browser and kind of, in a way, redefine what they're supposed to be doing. Because without roping the perimeter of SASE SSE through the browser, there's absolutely no way that you can go about protecting that data coming out of the enterprise. Okay. Anyone here not yet convinced that DLP in the browser? You need this book. Here you go. You have a question? Okay, we'll go through the questions. Just to kind of make sure questions are going in the right order. I'll probably have him give it. You can just put the question in. Okay, but I'm going to ask a question for the book. Okay.
All right, everyone. Just as a reminder that we do our questions via Slido. So I'm handing the iPad over, and Vivek will be able to check out the questions that have been submitted. We've only gotten one so far, so just a reminder, you just go to sli.do and enter in the code BSidesSF 2025, and we're in Theater 6 again.
Okay, sounds good. I'll just read out the question. So will this work if all the traffic goes through enterprise browsers, right, which is browsers where you can control things? That's the whole point of the talk. is if you're able to control what's happening in the browsers, whether it's enterprise browsers or extensions which go ahead and provide browser security, you are able to monitor every single thing happening. And that's exactly what you're trying to say is, if the browser is an application platform, then you need something browser native to go about protecting. Okay. I don't have any more questions here. Someone was asking a question here. Anyone? Any other questions?
If you just shout it out, I'll try to ask it again on the mic for everyone to hear.
Go ahead. So I think if you're not
the question?
Yeah, I got the question. Okay, I'll repeat the question. So his question was that if you're not using enterprise browsers or any form of browser security, how do you go about solving this problem, right? Simple answer, no, you can't. Similar to if you don't have an EDR or an antivirus, how do you go about at least getting a chance at figuring out whether malware or ransomware was downloaded? And that's the big blind spot at this point in time is, given that you can transform change data as you want within the browser, if you aren't having anything there or you fully control it, attacks are going to get bypassed. Okay, gentleman there, question? Or you want to add something? Exactly. And just to add on to your point, I think we are running out of time. To add on to your point, we've seen attackers even go ahead on the endpoint and kind of go ahead, call the browser out, but in a headless way, and then using that to exfiltrate data. So Mandiant and a couple of these guys put out some attack research around how you could actually use headless browsers and still go ahead, get the beacon across and all of that, even if SASE SSE was running. And there's a lot of interesting, I think, recent research around all of this. Because if all your traffic is going through SASE SSE, and you're probably infiltrated the endpoint, and there's ransomware, malware, something running, then how do you really now exfiltrate all of that data, right? And the best way seems to be, once again, via the browser. Now, you can't package in a new browser because that would be a new untrusted application running, would probably light up every EDR out there. And this is really where, if you could just go ahead, run the existing browser in headless mode. The other variation that we've actually seen is the installation of browser extensions. And both side loading it as well as somehow having the user install something. I mean, the most common attack we see now is a new version of ChatGPT comes out. And at that point in time, attackers will put out on social media saying, install this extension and you'll get free access. And those extensions start to exfiltrate data and whatnot. Okay, running out of time. Thank you very much.
Oh, you want to do two more?
Okay.
We still have 2 more minutes? All right,
Absolutely.
let's just read it out from Slido, though. Is there any difference for mobile browsers on managed mobile devices?
Okay.
It's the second question down on there.
Is there any difference for mobile browsers on managed mobile devices? Not really. Now, the only downside, of course, is given that on any mobile platform, iOS or Android, there's very little you can actually do at the operating system level, right? Because you've been locked out. People have tried to go ahead, use proxies. The closest one which we've seen is actually deploying an application with accessibility mode turned on. And that's a little superpower with which you can monitor a lot of what is happening on the device. And we've seen some attempts kind of like happen there. Have you looked at CyberHaven that does not rely on regex? Yeah. By the way, the whole CyberHaven attack which ended up happening, we were the first to disclose. We've looked at a couple of this. I think in interest of time, we'll try to post a more detailed response. Last but not the least, amazingly, this was Audrey's very first research talk at any conference. Personally, I thought she was amazing. So, thank you.
Thank you, Vivek and Audrey.